If y equals f of x, then x is called the independent variable, or the argument of f, and y is called the dependent variable, or the value of f at x. So in this case, x would be your domain, and y would be your range. But you could technically use any letters for those things. Alright, find the domain for each of the following. For this first one here, you could pretty much plug in anything for x, right? So the domain, whoops, a little bit slanted there. So the domain would be all real numbers, or negative infinity to infinity. Okay? For this one, you cannot let the denominator equal 0. So whatever x is, this cannot equal 0. So if I factor this, actually, I'll just add 4 to both sides. X squared cannot equal 4, so x cannot equal positive or negative 2. So here the domain is from negative infinity to negative 2, and from negative 2 to 2, and from 2 to positive infinity. Now I'll box these. There we go. Alright, now for the last one, in a square root, hopefully you guys remember that you can't have a negative number in a square root if you're going to get a real solution. So this, what's inside the square root, must be greater than or equal to 0. So I'm going to subtract 4 from both sides. Now I'm going to divide by negative 3. Hopefully you guys remember when you divide by a negative number, the inequality sign switches. So t is less than or equal to 4 over 3. So the domain is negative infinity to 4 over 3. Now in this case, because it's less than or equal to, remember, this bracket means it includes that number. So before I was only using parentheses, but here, because it could also equal 4 over 3, I'm going to use a bracket. Alright, I'll let you guys try this one. Remember, the denominator cannot equal 0. Alright, finding the domain of a function defined by an equation. Alright, this is pretty much just a summary of everything we just did in the previous 3 examples. Start with the domain as the set of real numbers. If the equation has a denominator, exclude any numbers that give a 0 denominator. Kind of like up here, when we had this in the denominator, I set this equal to 0 because this cannot equal 0. And then I found out that x can't equal 2 or negative 2 because that would give a 0 denominator. And so I excluded those things in my domain. Also, if an equation has a radical of even index, that means a square root or a 4th root or a 6th root, 8th root, any root with an even number. Exclude any numbers that cause the expression inside the radical to be negative. Okay, so once again, what was inside the radical had to be greater than or equal to 0. And then I solved for t. And this is what I got. Okay, so that's that. Example 10. Express the area of a circle as a function of its radius and find the domain. Okay, so hopefully you guys remember the area of a circle is pi r squared. And that there is the area of a circle as a function of its radius. You could even write a of r, since r is the variable inside the equation. Doesn't really matter. Now technically, you could plug in pretty much anything in for r, and you would get a number. But if you think about it, if you have a circle, the radius is the length from the center to the side. This can't be negative. You have to have a positive number. You can't have something be negative 3 inches or something like that. Okay, so r has to be greater than 0. Also, if r was 0, then you don't even have a circle. Okay? So the domain, oops, is 0 to infinity. You guys try this one. Alright, some difference product and quotient rules. This is actually a mistake here. Sorry. Shouldn't be different. It should be difference. There we go. F plus G is F plus G of X is basically just F of X plus G of X. So just take the two functions, add them together. Same thing with subtraction. Oops. F minus G of X is the same as F of X minus G of X. And when you multiply them, this is the same as F of X times G of X. And if you divide them, same thing once again. Of course, if you divide them, then G of X cannot equal 0. Okay? Alright, let's take a look at example 11. Let f and g be two functions defined as this and this. Here and here. Find the following and determine the domain of each case. Okay, so if I'm going to add these, I'm going to have 1 over x plus 2 plus x over x minus 1. In order to add fractions, you have to find a common denominator. So I'm going to multiply this side by x minus 1 over x minus 1, and this side by x plus 2 over x plus 2. Okay. Sorry, I didn't give you guys really enough space. So from here I have x minus 1 plus, distribute the x squared plus 2x, all over x plus 2, x minus 1. I can combine like terms. X plus 2x is 3x. And I'll write that here. So x squared plus 3x minus 1 over x plus 2, x minus 1. Now if I'm subtracting, pretty much the same thing except this becomes a minus. So I've got x minus 1 minus x squared plus 2x all over x plus 2, x minus 1. I'm going to distribute this negative. So I've got x minus 1 minus x squared minus 2x. Oops. And once again, x minus 2x is negative x. Once again, I apologize for the lack of space. I clearly did not give you guys enough room. You guys are welcome to work on a separate sheet of paper if you want. There's so much room down here too. Alright, I'm actually going to solve, let's see here. I'm going to solve C down here somewhere, just so that there's enough space. So we've got f times g of x. Multiplying fractions, in my opinion, is much easier than dividing fractions. I've got 1 over x plus 2 times x over, I think it was x minus 1. Oops. And you just multiply across. So I've got x over x plus 2 times x minus 1, and then you can FOIL this. So I've got x over x squared minus x plus 2x minus 2, or x squared plus x minus 2. There you go. Dividing fractions is pretty much the same as multiplying fractions except for one difference. So I've got 1 over x plus 2. You're going to flip the second fraction and multiply. So if I'm dividing by x over x minus 1, this is going to flip over and I'm going to multiply. And then you just multiply across. So I've got x minus 1. If I distribute the x, I get x squared plus 2x. There you go. Alright, this one should be a little bit easier to work with because there's no fractions. Okay. And you know what? Because there's no space, don't worry about the domain. Okay. I will give you extra credit if you find the domain. Just let me know tomorrow that you found it. You'll probably have to work on a separate sheet of paper, but I'll give you points for it. Alright, and that's it.